Hey, welcome back, everyone. I know it's been a few days, and I'm sure you missed me, but hopefully you had a chance to learn some things from Hank Green, who does an outstanding job, him and his team, in terms of putting together videos on digestion. I'm alive and well. In case you were nervous or worried, I'm just fine. And hopefully you are too, and hopefully everything with your families and everything is, I know it's a tough time that we're still going through and we're still dealing with, but I really, really, really do appreciate you participating in this class and trying to learn about things that are going to help you down the road. And understanding about the human body is something that I think is very valuable. And the more you know about it, the better decisions you'll make as you get older when you encounter situations similar to what we're going through now. The unit is called Everything Poops. I came up with that name, kind of a catchy name, but we do see a lot of organisms around us, and we deal with poop almost every single day. Whether you have a new dog or a new puppy like we do, or you dealing with animals at the golf course, like I see sometimes, like Canadian geese and all the feces that they leave around and things like that. Each and every one of us has a reason for why we manufacture this stuff, and that's what you've been learning about, sort of. So we're going to kind of go over that a little bit today and make sure that if you have any questions or if you're any kind of not understanding what we're trying to get at here, you have a better idea of how things are working in terms of human digestion and maybe other animals as well. Loose ends. All materials are due today, Friday, May 15th by 11:59 p.m. So I know you had some Google Docs this week that were POGL type docs where you were sort of like looking at information and answering questions. Some of you got some feedback on some of those early ones, and I'm still working on grading the other ones, but those are going to be due. All three of those docs are due today. You also have a form that's going to be due today, which will be a simple, just 10-point quiz on the digestive system. And there could be a question or two even from this presentation that is on that. Really what you want to be able to do with anything in your study and in terms of the human body is to be able to explain what it does, why it works, and how it works. And that's what we're going to kind of look at a little bit today and see if we can even apply it to other situations. And again, we'll have a short quiz today that you can look at. One of the cooler things that I've encountered from teaching anatomy, physiology, and teaching biology is that there are some websites that provide you with older artistic impressions of the human body and the systems that make it up. And I thought this was a cool one. This one, the background for this particular slide, it comes from a rock painting from 6000 BC. So 8,000 years ago, if we really look at it, quite a long time ago. And this drawing was made by some Aboriginal person or native person that lived in Australia at the time, and is an X-ray style figure, and shows you that even back then people were curious about what were the parts of the human body and what did they do. So let's get into what we're trying to get at here. As you can see here, we have some pictures that I pulled up. Again, like I said, this is from the National Institute of Health and their artistic gallery in terms of the human digestive system. You can pull them from there, or you can do internet searches. But we have a really good picture here of some parts of the digestive system and what you've gone over. Some of the key things that we've covered this week include how we went over the human digestive system. Is we started with learning a little bit about mechanical digestion. And mechanical digestion, we know, is just basically the physical digestion or breakdown of food and pieces like that. It starts in the mouth, where we start to chop things up. And then obviously it can continue a little bit in some of the other organs. We know that mechanically the stomach can move stuff around and things like that. But most of your mechanical digestion occurs in the mouth. And we learned that, we have teeth and things like that. You should have learned that, you have a small little flap in the back of your pharynx that keeps food from going down your trachea into your lungs. That's called the epiglottis. Kind of a cool little thing to know. But we then know that food is going to travel down this tube right here, and which most of you will already have learned is the esophagus. Okay. The esophagus is a tube that basically allows food to travel down. And as it travels down, we know that there's two valves located in the stomach, one here and then one at the base of the stomach too. It allows food to kind of sit in the stomach with stomach acid, which is going to sort of start to initiate more chemical digestion. But that stomach acid is also like a protective measure too, to protect your body from pathogens like bacteria and things like that that could harm you. Down here we have the inside of that stomach, and you learned a word called rugae, which allows the stomach to expand and become 3-4 times bigger than it actually is, and in some people even larger than that. You know, guys like Joey Chestnut and Takiro Kobayashi, some of those professional eaters, their stomachs can get very, very large. When they're in those competitions where they're trying to eat as many hot dogs as they possibly can. And so we continue on with that digestive system, and we know we can move into your upper area of your small intestine, which is known as the duodenum. We have an important thing here, your gallbladder, which is secreting bile that's stored, and that bile comes from that liver there. And that bile is going to help break down fats. Remember, the nutrients that we're trying to break down during chemical digestion is we have fats, and we also have proteins, and we have carbs. Those are the three main nutrients. I know there's a fourth one, nucleic acids, that are mentioned. But in that case, nucleic acids are sort of like the DNA that you're consuming, and that's not really a nutritional thing so much, but these are the three things that you're going to try to break down chemically. And fats are going to be broken down by that gallbladder, that bile that is secreted through there. As food travels through there in this particular organ here, you know, you get a lot of chemical digestion here. So this is a lot of chemical digestion. I'll just write down abbreviation CD in this area, all from that pancreas, which is located right here, that's secreting enzymes that are breaking these molecules into smaller molecules so that we can then undergo what is called nutrient absorption. And that nutrient absorption is going to take place all in the small intestine here. And then we know that if we blew up one of these things and we looked in the inside of one of these small intestines, you saw in your yesterday's POGL that there are tiny finger-like projections that are called villi that line that particular small intestine that allow food to be absorbed and go into the bloodstream. All these, all your intestines here are going to be connected to lots and lots of capillaries that are going to absorb nutrients and put that into the bloodstream so that can be delivered to parts of the body for whatever you need it for. So all these things that are broken down from these molecules over here, the proteins will break down in amino acids, the carbs will break down in simple sugars, and the fats into fatty acids, and they'll be delivered to different areas of the body. So nutrient absorption is huge in that small intestine and that jejunum and ileum sections of that. And then that's why it's so long, and you stretch it, it's the length of a room. Your intestine would be the length of my classroom. I wish we were still there, but we're not. So you can imagine what that would be like in terms of if we stretched it out. And so you have a better idea of anatomy from those lessons, and you should have a pretty good idea then of what's going on in this digestive system. We call these items up here accessory organs right here. So the pancreas is an accessory organ. The liver is an accessory organ. The gallbladder is an accessory organ. What that means basically is that food doesn't come into direct contact with these things, but instead these things are producing the bile and the enzymes and things like that that are being released into that small intestine to help with breakdown. What is everything else? Well, everything else is part of what is called an alimentary canal. So if I change the color of my pen here, we know that food travels down this alimentary canal. It goes into the stomach through those sphincter valves. Such a cool word, the word sphincter. And then we go through, and then we wind all the way through these small intestine, like we do here, and we loop back up into the upper colon or large intestine, and then out through the rectum, through the anus. This little white item right here, I've had that removed from my body. It is a appendix and is typically not used in digestion as a vestigial structure that at one time was beneficial, but no longer serves a real purpose. There's some documentation that says that it does. Some modern day research says it has some things to do with how your body can respond to certain ailments in your digestive tract. So anyway, that's the alimentary canal. We have to understand that that red, that's what that means there, alimentary. And that's basically a food tube, which allows food to travel through. So these are just, again, things that you probably know from Hank Green and also from doing some of those POGL documents as well. So pretty good there. So why is understanding digestion important? Well, I mean, for our own bodies, it's important because we want to have a better idea of how our body works and what's happened to PT. You know, he got real sick, so we want to have an understanding for that. But it's also important to understand how other creatures are and what they're doing and how they're handling their food. And in this case here, we came across this I believe female, probably one of the bigger female snapping turtles that I've seen. I actually saw this at El Dorado Golf Course 2 days ago, and she's probably looking to lay some eggs. One of the larger snapping turtles I've seen in a while. You can see that just big claws on that back leg there, and big nice shoulders there. And she's got a little decoration here, wearing her little necklace or her little shawl around her neck here that she's designed. But you know, I wouldn't want to get my finger too close to her. Again, very a highly adapted creature that can live for a long time. Who knows? This turtle could be 30, 40, could be older than I am. Very possible that it is, as large as it is and the size of the specimen. So how does a turtle digest food? Does it have the same things that we do? Does it have accessory organs? Well, if we look over here, sure enough, we see that it has a liver and a pancreas. So yes, turtles do have accessory organs. That means they have organs that are going to be secreting enzymes and bile and things like that to help them with the food that they eat. Turtles will eat a lot of small fish and crayfish and anything that they can catch. They're sedentary predators. They sit and they wait for their prey to get in front of them, and then they snap their tremendously fast necks to jut their head out and then obtain prey. But those accessory organs are, yes, so we can check that off for sure in terms of what a turtle is going to use is definitely going to have accessory organs in this case. Does it have an alimentary canal? Well, of course it does. It has the esophagus, and food is going to travel through that stomach, and it looks like it has a duodenum and the small intestine is fairly wound up. So we look at a creature like a turtle and think it's fairly primitive, but it's very similar to us. And is there anything other that's different here? Well, they mentioned a cloaca here. And that serves as sort of a dual purpose type feature for both liquid and solid waste. And so that is something that is a little bit different, something we don't have, but it does. So I'll write that down. It's something you don't necessarily have to remember. But when we compare other organisms, it can strengthen our understanding of how our own bodies work. So snapping turtles, pretty cool. You'll see them all around you. If you get a picture of one, feel free to send it and I'll put it in the stream. They're pretty cool. Then we have something as simple as an earthworm, and we used to do dissections of these particular organisms right in class, and they're interesting to talk about because, again, we can see, do they follow the same checklist? Comparative anatomy-wise, well, sure enough, it does have a pharynx, which is located up here, not like ours, of course, but it is able to pull in food, and that food will travel right through this whole thing here. So it does have what is called an alimentary canal. So we definitely can check that thing off there. We know that food is going to travel through that. Is there accessory organs that help with digestion? Is there a liver, a pancreas, or anything like that? Well, in this case, no. This particular creature doesn't have that. It has things like what are called a crop and a gizzard, which are located right here. This, I believe, is its crop. And you probably heard of the word gizzard with chickens and things like that. Sometimes it's another little kind of a specialized stomach that is used to grind up food because these organisms don't have teeth. But those are those items there. These are more for reproductive purposes, and obviously we have the circulatory system here. So, but there is no accessory organs. So in this organism, digestion is fairly simple, and it's gonna. That's why the earthworm is pretty long behind what is called the clitellum here. After that, it's almost all intestine, and that's where it's going to be pulling its nutrients from. Is from that intestine that runs along the base of that. So there's the intestine for that particular creature there. So earthworm, not as advanced as we are, doesn't have accessory organs, does have an alimentary canal. That's about all that's similar in that case there. All right, and so let's go to the next one. Next one is interesting to talk about. This is called a hydra. And so let me write that down for you. And sort of got kind of like a very similar to the Greek god. I know there's some Greek mythology that's related to this term, but the hydra, that's usually an animal with multiple heads. In this case, it has tentacles, and very similar to what you would see in a marine creature as an anemone. So sort of a close relative of that. And so how does this right now, this down here, this particular hydra is trying to consume another they're not necessarily microscopic. They're pretty small. I would say like zooplankton type size. So this is something this is a microscope for sure. This is magnified probably, I would say 100 times, from the naked eye. So these things are very tiny. You're not going to see one unless you really, really look close. So it's trying to eat this Daphnia that's located here. It's got its tentacles wrapped around it, which do have some stinging cells in them and able to sort of paralyze whatever it's capturing. So it has that. And then it's going to try to digest or consume this thing. Pretty cool, huh? And so it has a mouth. And so food like that, Daphnia or whatever, is going to go into this particular thing here. And this is called a gastrovascular cavity, or GVC, sometimes its abbreviation is. And basically what that means is that once it comes in, it's going to be absorbed. There's enzymes and can break down stuff and help absorb things. You can see that over here with these cells here. But whatever wastes are created and whatever it doesn't eat is going to go right out the same door. All right. So we don't have a couple things here. We don't have accessory organs because this is a pretty primitive creature. We don't even have a liver, a pancreas, and things like that. So none. So we don't have that. No, we don't have that. And we don't have an alimentary canal either. So no there. So not everything has a mouth and anus. This has a mouth, but no anus. So food just simply goes into the gastrovascular cavity and then comes straight back out. So I've kind of in this presentation gone downhill in terms of advancement. We're not, and we could keep going down to like unicellular creatures if we wanted to, that would have like very, very, they just absorb whatever they can through simple diffusion. But you can see here in the hydra, an animal, true, but it not necessarily does it poop, okay? If it does, it's really just a tiny, waste that you would never even see. So that's the hydra and how that works there. All right, and so that kind of summarizes how you can look at digestion. Couple last things here. In human digestion, I think it's very interesting to talk about the annual Nathan's hot dog eating contest that takes place, I believe, in New York City. And we have our two very famous competitors here, Takiro Kobayashi and Joey Chestnut. Joey Chestnut has the current record of hot dogs, and I forget the time is, but I don't know what the time is when they do this, but Joey Chestnut has eaten 74 hot dogs, okay, in the competition. And Takiro Kobayashi he was the one that kind of came up with the whole dipping the hot dog in water to speed up the ability to eat them. He held the record for a long time, but recently, in the past 6 or 7 years, Joey Chestnut has dominated the sport. It is a sport. They do win money. Interesting to see how they train or to learn about that. There is a Takiro Kobayashi interview on one of my favorite podcasts called Freakonomics, which is hosted by some guys that really do some cool interviews with a lot of intellectuals around the United States. Could be professors, could be professional athletes, could be wide, anyone. popular politicians and things like that. They do some really interesting interviews, and one of them is with Takiro Kobayashi through an interpreter, and they talk about how he stumbled into this particular sport and how he trained and how his body adapted to things like that. So kind of a cool thing to look at there. All right. So if you get a chance, check that out. So can we apply this to my situation? As you saw or witnessed in the video, I look pretty bad, pretty rough. There's a picture in me right there. It wasn't good. What organs were affected in my situation? How are molecules changing? How are they moving? What's going on with Petit? And we're going to look at that probably next week. Some of you have proposed some great ideas in terms of testing. Some people wanted to test my blood. Some people wanted to test my stool. Some people wanted to test the water, wanted to test the food, all sorts of different things. So we're going to look at that a little bit more closely next week. Just to give you an idea of something that maybe I could have is, what about this disease here? Some of you may have heard about it before. It's called cholera. And every year there are a certain number of people that get cholera. And this graph is broken down into the Americas, Asia, and Africa. And you can see there's a large outbreak of cholera in the Americas in 2011. I would think that might have something to do with a possible earthquake that occurred in Haiti. Maybe you could check on that, but I want to doubt that's what that big number is right there. A lot of these are certain events that have occurred in poor nations, but cholera is something that kills a lot of people every year and is a disease that affects the digestive system. Is that something I could have? I don't know. We could look and see if it's that or maybe something else. So we're going to be investigating that, and I just want to show you a graph of something that is out there. All right. Thank you again for another great week of learning. All of you out there that completed those assignments are at that Mario level. Again, thank you so much. And those of you that are trying to get there, all of you Yoshis and Toads and that are, giving your very best every day, the 30 minutes that we ask of you is very much appreciated. I can't say enough about how much I enjoy looking at some of your assignments and some of the responses that you give. And those of you that take the feedback and do it again. I mean, and try to get the answers right. You're moving in the right direction. You're doing the right thing. I know there's a lot of people out there that say, you know what, I could just get general credit. Who cares? That's not the way to do it. We're going to need people. We're going to need doctors. We're going to need healthcare professionals. We're going to need people that understand this digestive system. And hopefully some of you may want to move that direction. Maybe you have parents that are in the medical field, or maybe you have family members that are doctors or dentists or whatever. I hope that you're inspired by learning about some of these things, and I hope that you feel like you are actually doing something, because you are. So I want to say from the deepest part of my heart, thank you so much for helping out with what we're trying to learn. And if you see anything that I can improve on or help you with, let me know. Thank you again for another great week of learning. Go find some morel mushrooms. If you find any, take a picture and send it to me. All right. Thanks.